Hey, it's Peter from DevMentors and welcome to the 9th episode of our Building FeedR series, in which we build the sample microservices based solution using .NET 6.0. And in this episode, as promised in the last one, we are actually going to integrate with the real message broker. There is plenty of message brokers, service buses, or event streaming tools that you can choose from. Just to mention tools like RabbitMQ, Azure Service Bus, AWS SQS, Kafka, NATS, and many others. So for this episode, I chose something which is quite cool. It's getting more feature-rich, more mature. Some people claim this is going to be a Kafka killer. We'll see about that. But what I decided to go with is the Apache Pulsar, another open source, very promising message broker, or even more than just message broker. It's also suitable for streaming the data. But just to be specific, in this episode, we'll see how we can use the Pulsar to actually publish the message. So just like we mentioned in the last episode, the goal of having the message broker is not maybe for streaming the data, which for some cases the typical message broker might not be sufficient, for example due to some, let's say, performance limitations. But in our case, we want to, for example, go with Pulsar or another message broker which will provide to us some features such as message persistency, guaranteed delivery, or maybe some kind of load balancing, and a few other features which are actually very important for our business perspective. So our, let's say, core feature, or the core responsibility of our microservice will be to never lose the business data. So this is why we decided to go with the real message broker. So we are not going to implement our own message broker using the database, which of course we could do, but instead we'll see, for example, how easily we could exchange the events, exchange these messages between our microservices using the Apache Pulsar. All right, so let's plug in the Pulsar into our infrastructure. So as you can see in this nice landing page, the Pulsar is pretty rich in lots of cool features, and they claim like a very nice performance for this piece of infrastructure. But in our case, we don't need this, millions of requests per second, with millions of messages per second. We are just going to play with the simple publisher, subscriber, or consumer producer mechanism when it comes to the messages. We will want our messages to be persistent, so we won't lose the data. And this is, let's say, the whole requirement that we'll have for now when using the Apache Pulsar. So in order to start this, as you can see in the docs, there is this command that you can run from the Docker. Now, this will run our standalone version of the Pulsar locally using the Docker. If you want to, provide some high availability feature using clusters and so on, of course you can do this, but this would take a bit more time, a bit more advanced configuration to make it work. So let me jump into my console and let me just copy and paste this command. So I'm just going to run this Pulsar on these two default ports as this standalone edition, and this should be running the Pulsar along our Redis. And of course we could take this Docker definition and we could just put it there into our infrastructure next to the Redis, so we can run the Pulsar along with the Redis whenever we start the whole system. So that's the first step. Now, before we move on, if you would like to get a glimpse, if you'd like to get an overview what's going on within your Pulsar, let's say, instances within your service, you can also start this Pulsar Manager, this official dashboard, this interface for the Pulsar, a very nice tool. And you could also configure this and run this from the Docker to actually see what's going on within your Pulsar server within your, what are your messages, who's being connected to the Pulsar, who's the subscriber, who's the producer, what is the throughput of the messages, and lots of cool features and statistics. You could find them here. And when it comes to .NET clients, .NET libraries, we can find at least two libraries, the official one, pulsar.pulsar, and let's say the unofficial one, pulsarclient.net. As you can see, both are being updated quite frequently. Both have a lot of nice features built in. Of course, there are still some to be implemented, but most of the important features are already there, and both of them have very pleasant API to work with. And within this, let's say, episode, let's just stick to this official .pulsar library. So into our shard, what we are going to do is that we are going to install this Pulsar NuGet package. So let's just look for the Pulsar, and let's install this .pulsar. This is the library that we are going to use. Let's say this official one from the Apache. So this is the .pulsar. And now, since we already have in place our two interfaces for the message publisher and message subscriber, which are being used as a template internally. The publisher will be the aggregator, publishing our order placed events every, let's say, few seconds after receiving this currency pair values for, let's say, 10 times in a row. And then we have our subscriber, which is going to be the notifier service. So for example, this service could maybe send an email to the user for whom the order has been placed, or whatever, send a SAT notification, whatever we can think of. We have this template for messaging in place. So now we need to publish and receive our messages by using the real message broker, not some in-memory dumb implementation which doesn't do anything, since we are running these two microservices separately from each other, and we need to integrate them through the network. And this decoupling, this black box that will be providing this integration, and as well the coupling with these two services, so they don't have to talk to each other directly. In our case, we will be the message broker, and we have chosen to play with the Pulsar. So let's make a new directory under our shard, and I'll call this one Pulsar. And just like we have one for Redis, let's call this one Pulsar. And internally, let's just expose a new class, and I'll call this one, by following our convention, the extensions once again. And let's expose a single methoder, public static iService collection at Pulsar. And this will accept, of course, our iService collection services. And here, what we are going to do, as you can imagine, we are just going to provide the implementation for our message broker, for our message publisher, and our message subscriber. So let's do the following. So I can change this to look something like services, and then let's say add singleton. So for our iMessage publisher, I want to have something like, let's say, Pulsar message publisher. And for our iMessage subscriber, I want to have something like Pulsar message subscriber. So let's do it this way. And now let's, of course, add these two types somewhere here. So down below, let me just add them here. And let me just move these two, for now, empty types to the dedicated files. So this will be our publisher, and this guy will be our subscriber. So the subscriber and the publisher for a Pulsar, and let's just move them here to the separate files. Now, we have this in place already. So actually, before we implement this subscriber and publisher, let's jump into the two services that will be using Pulsar, at least for now. So the first service, being the publisher, using this message broker, will be our aggregator service. So here, keep in mind, after this add messaging, we are going to code add Pulsar. After this method, because internally here, we are registering our dummy implementation of this publisher subscriber. So we want to override this implementation by calling add Pulsar, which override this publisher subscriber with Pulsar implementation here. So we have to call this after add messaging. And the next service will be the subscriber of our messages coming from the message broker, will be this notifier. So here I'm just going to call add Pulsar once again. So looks simple, looks good. Now let's get into the implementation of our publisher and our subscriber. So maybe let's start with the publisher of our Pulsar, right? To our Pulsar acting as a message broker in this scenario. So the first thing I'm going to do is through the constructor, I will inject the serializer because we'll need some way, as you will see, to serialize our data. And let's, for now, keep things simple, and let's also inject here the logger. So something like this. So the logger and the serializer. Now let's instantiate the client. So by following the docs, the specification of this Pulsar library, I can call Pulsar client and then builder and then build. Now, of course, keep in mind that I'll keep this here in to-do list. Extract Pulsar into app settings, right? And dedicated options type. So just like we did, for example, just like we implemented our, for example, weather feed for our HP client, we could do the same here, right? So we would need to extract this, let's say, connection strings or maybe some other settings into the dedicated file, into the app settings dedicated section. So we could, just like for Redis, like we have, for example, Redis section here, we could do something like, let's say, Pulsar, and just provide here all the data, all the connection string, and all this stuff to, inject from the app setting instead of hard coding them. But for now, to keep things simple, because we know how to do this easily, we'll just go on with the episode, with the content, and we can extract this later on. It doesn't really matter for now. We just want to have things up and running. That's the important part for now. So I'm building the client now. And before we move on, so what I want to do, I need to provide some unique producer name. So what I mean is the following. So in order to make the producer publisher of our messages, I need to do something like following. So I can ask our client, as you can see, client new producer, to create the producer of the messages. And here, by following this Fluent API, I need to provide the producer name. As you can see, I'll need to provide this for the subscriber, but I can provide a producer name. So maybe I could have this distinction. Who's producing the messages? So maybe I could do some filtering later on, or maybe even further. I could pass along the name of my producer to the other microservices because maybe they will be interested. Who's pushing this data? Who's producer of this message? Maybe they'll need this for some kind of logging or tracing, whatever the reason is. So let's think how we could actually grab the producer name from our type. So we can use a very simple, let's say, reflection, or maybe not reflection, maybe just a base assembly type to pull our producer name. So let's assume that when we construct this for the first time, we'll assign to the producer name string property the following. So I will ask this assembly get entry assembly. So the class that will be using my Pulsar internally for the full name. So in order to remove these complaints to get rid of the complaints from our compiler, I'm just going to use these question marks here because this might be null theoretically. So I'm going to take the full name of this entry assembly. I'm going to split this by the comma because this would give me, let's say, the full name, something like feeder.aggregator.pricing handler and then blah, 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 assembly version 1.0 and so on and so on. So I'm going to split this by the comma, and then I'm just going to take the first part, which will be the name of my microservice. In this case, for example, the FeedR aggregator. So let me just take it here. Let me make this to lower invariant. Otherwise, if it's null in any scenario, I'll just keep this as an empty string. So just some small dirty hack to get our producer name automatically. And once again, this is potentially something that you could maybe extract to your application settings. So let's specify our producer name here. And now the most important part. I need some kind of a topic. So the place to which I'll be sending my messages. Topic, subject, exchange, depending on the message broker, the naming might differ, but in most scenarios, it's pretty much the same idea. So I need some specific unique name to which I'll be pushing my messages. So the topic will be, of course, provided here as my parameter. So let's say orders, weather data, users, invoices. But I want to make this persistent. So I don't want my topic to, for example, be gone or automatically removed when the application stops. Or I don't want my topic to receive the message, and if there is no subscriber, no consumer of this message, to just remove this message. I want this to be a persistent topic to keep these messages, for example, in memory or maybe in some database until the actual consumer of these messages arrives, connects to. So this consumer, even if the consumer was, let's say, offline and available, had some downtime for even half a day, the topic shouldn't care. It will just push the messages to this consumer when it's back online again. So by following the Pulsar convention, I'm going to make a persistent topic. So this is the reason why I'm specifying this persistent here. And then I want to make this public default topics a schema. And here I'm just going to provide my topic name. And then let's just call something like create. All right, so that looks good for now. So there's my producer. Now, the next thing is, how can we actually push this data? So if we take a look, the producer has something like send. So it's asynchronous, returns a value task. It can be asynchronous. So the send expects from us some kind of data, the read-only sequence of bytes. And if you remember, within our serializer, we are now working directly pretty much with the string. So not an issue. Let's just extend our serializer with two following methods. So I will simply copy and paste these two. And the first one for the serialization, I will call, let's say, serialize bytes. And this will return me the array of the bytes. And the second one I will call deserialize bytes. And this will accept the byte as the value. So we have serialization and deserialization for the string, and we have the serialization and deserialization for the bytes as well. So let's jump into our implementation using system.txt.json, and this will be very, very simple. So we can directly make use of our JSON serializer, and then in this scenario we can call serialize to UTF-8 bytes, provide our value and options. And here we can do something similar. So JSON serializer and just serialize to this type of T, and then provide our value and the options. So this is built into the system.txt.json. So very easy stuff. So now coming back into our Pulsar message subscriber, what we can do is the following. So now we can at first serialize our payload. So the payload will be our serializer and the serialized bytes and our message. So this is like the first thing we need to do. And just to make it the proper one, let me just take a look here. So we have T must be a class. We have T, which must be a message. And in our case, when we are actually adding this constraint, we need to ensure that this is going to be a reference type as well. So let me just put it this way. So just to make sure that our message will be also a class. So we can actually make this additional constraint here to our publish async. So here I can extend this to be of class as well. And also for the subscriber, here let me just fix this or improve this. So this has to be a class, and also for the subscriber, let's just assume that this is always going to be a reference type. So let me fix it here to be of class and iMessage, and also let me fix it here within our subscriber, which for now is dummy. Okay, so coming back to our Pulsar, we can now serialize the payload to the bytes, and we can send the message. So producer send, provide our payload, and this will give us back some kind of unique message ID, and we can of course await this. And finally we can do something like logger log information, send a message with ID, and there will be our message ID like this. And what I can do now is, before we implement our subscriber, let's just see if the things do work as expected. So let me put a few breakpoints here and there, also maybe here. So let's start now our aggregator, which, if you remember, it will be pushing this data. So here in this method, it will eventually send this order place event to the broker. So let me run this guy in the debug mode. And of course, I'll need to run our quote service as well to actually receive this data in the first place, because at first it will need to receive the data here in the background service, and then it will be able to make some order and push the order place event. So what's happening now? I'm starting my service, and let's take a look. So the producer name in the scenario, when calling this get entry assembly, if I were to evaluate this expression, let's take a look. So this will give us the whole name, right? FeedR aggregator, comma, version, culture, public key, right? So this is why I added this comma splitting there. So the producer name is going to be just FeedR aggregator, lowercase. Great. So the service started. Now let's run our quotes so we can start sending some data. All right. And let's jump here to start this quotes feed. And after 10th currency pair, we should hit our breakpoint and send the event. So let's see. So there's our integration event that we are going to send. And let's take a look. There is our producer with this unique name. There's our payload. And now we are sending the message. So let's take a look. Producer sent. And the message should be sent, right? As you can see, message ID containing this few sections, and we send the message through the Pulsar. So everything works as expected, right? It looks good. At least it's not breaking anything. So even though we have no subscriber for our Pulsar broker yet on the second side, so that the notifier service isn't subscribing the data yet, it looks that we are now able to at least send the messages, to push these messages further through this Pulsar. The data is being somehow sent. So yeah, let's stop our services. All right. So we have stopped the services, and let's see if we can somehow subscribe to this data. So now we need the subscriber side. So let's jump into our message subscriber. And let's start with the following. So at first, we are going to inject, once again, through the constructor of this subscriber, the serializer, because as you can imagine, we'll need some way to deserialize data. And of course, let's also inject here, for example, our logger. So subscriber, and this will use serializer and the logger internally. And just like we did in our publisher, we can make use of this client name. Okay, so the client name will be our Pulsar client. Sorry, the client instance will be our Pulsar client builder.build. And now we can also do something like grabbing the consumer name. So here, let me just copy and paste this guy, and the consumer name will be the same simple idea as we have in our producer for our producer name. And now let's see how we can subscribe to some data. So the first thing that we are going to do is to provide the unique subscription name. So the subscription will be some kind of unique string, unique value that we'll be using in order to subscribe to the specific topic. Because as you can imagine, there might be multiple different microservices, let's say order service, user service, trying to subscribe to the same kind of event for their own purposes. So we don't want, let's say, only one microservice to get this data and the other will never see it. So this is the reason why we need to provide some unique subscription name. So in our case, let's assume the following. So the unique subscription name in this case would be, for example, the consumer name and then the topic. And then if we were to scale this horizontally, if we were to run, let's say, 5 instances of the same service, let's say the same notifier microservice, they could subscribe to the same subscription. They could reuse the same subscription name so that depending on the broker that you are using, for example, the message broker would take care how to distribute these messages, whether all the services should receive the same copy, or maybe there should be some load balancing, or only one service should receive the copy of this message. Because if you have this stateless microservices in place, most likely what you want to do is only to one service from the specific group of microservices, let's say from orders, users, invoices, microservice, to receive the event. You don't want 5 instances to consume the same event because it doesn't make sense in most cases. So this is going to be our unique subscription that we are going to use to subscribe to some specific topic. Now let's create our consumer. So the consumer, similar to our producer creation, we just call client new consumer, and then subscription name. As you can see, this is required. So subscription name is required. So we are going to provide the subscription, and then the topic. So I'm just going to copy and paste this topic. And once again, we could, for example, extract this maybe to some app settings or to some factory, how to create these topic names and so on. But for now, I'm just going to keep things simple and let's just call create. And once we create our consumer, I can do something like await for each. So it's using enumerable behind the scenes. So for each message in consumer messages, let's see consumer messages. And now let's say log information received a message with ID. All right, let's take a look with ID. Then there is our message ID, but there are more properties like schema related, producer name, and a few others. All right. So let's see message ID. All right. So let's leave it like this. And now we need to get our data. So we can ask for the payload. So the payload will simply call deserializer, deserialize bytes to our expected T type. And then from our message, we can access this data property, which is this read-only sequence of bytes. We have our span, and we could just do something like toArray or extend this deserialization method to also accept the spans. Whatever you can think of. It could be even more efficient, of course, to just directly, provide the span than to make this additional greedy toArray call here. So for the performance reasons, you would remove this and just extend your deserialized bytes with capability to work directly using the spans. And if our payload isn't null for any reason, if it were null, maybe there was some error. So if it's not null, let's just try to log this data. So at first, let's just do something as simple as log information, and I'm just going to log this as a whole. So let's say JSON equals serialized JSON. So let's just try to log this data, see if we received what we were meant to receive properly. And of course, we need to call our handler. So if the handler is provider, if the handler is a null, I'm just going to call this handler payload. So in our case, our notifier service should be able to log this information, since this is declared as this callback action for our handler for this orders topic. So this is our consumer side and our message subscriber. And finally, in order to let the Pulsar know that we want a next message, we want to acknowledge this message. So I'm just going to call consumer.acknowledge that I have received this properly, and please give me a next message if there is something more waiting in this queue, to receive, to be sent to me. So this is our Pulsar message subscriber. So this looks good. Now let's try to run all the services, and let's see if we can start our aggregator, start our data feed, start pushing our message to the Pulsar, and finally receive them within our Pulsar message subscriber, in this case being this notifier microservice. So let's run all the services one by one, and let's see if this is going to work as expected. So yeah, let's start with the aggregator. I'm going to run them in a typical release mode, or without the debugger in this case. Let's run our quotes, and finally let's run our notifier service. So let's run another guy here and let's run our notifier service. Okay. Let's see. And let me just check. Okay, I have called @Pulsar here. So this looks good. And I have called, just to make sure, @Pulsar here looks good. All right, so we have the three services up and running. Let's start our quotes feed. And let's see. So the quote started pushing this currency pair, so there it pops up. And now we should see order with ID has been placed and the message has been sent. And as you can see, we have received the message. So we have published the message to the Pulsar here, and our notifier has received this message. All right, so order ID symbol using this JSON logging internally, and then we have received this message, and this order has been placed. And of course, if there are more messages, there are more events to be sent, we would start receiving more and more events finally on our notifier side. So that looks good. Now let's take a look at the following. So let me just run this notifier once again. All right, so as you can see, it's empty for now. But what would happen if I were to do the following? Let's say the notifier is now offline. Okay, so the notifier is down. It's not really doing anything within its internal subscription logic, which of course is dummy for now, but that's not an issue here. So internally within its background service, it's just logging some data, right, somewhere here, and then it just simply acknowledging the message that it has been consumed properly. So let's say I would run my aggregator now, and I would run my quotes feed. So let's run these two services. So the notifier is currently offline. Let's say for whatever the reason, we didn't manage to deploy it properly. There was some error. We had to, make it offline. Whatever, something, for example, happened. So now I start my data feed, my pricing feed, and the aggregator, as you can see, will at some point, of course, send a message to the broker. So order has been placed for symbol with this ID. And then again, after a while, it will send another message. So let's say the additional event, and so on, for the Pulsar, of course. So let's stop our services. And now let's run our notifier. So now let's see what will happen. So I'll run the notifier. And once the notifier has started, as you can see, it has pretty much immediately received this message. So even though it was temporarily offline, the message waited for our consumer. The data, wasn't gone. So this is why it's that important when you work with the actual events, business-oriented events, that in most cases, you don't want to lose these events. So you are maybe fine if your service is temporarily offline and you receive this event, and if this event will wait for you 5 minutes, an hour, even a day, doesn't matter what the period is. But you want to receive the notification that something happened within some place, within some microservice in your system, and then you can maybe proceed with your internal workflows based on this event. And of course, you would get into this eventual consistency challenges because you can see there's some interval between you might receive this data, especially if you are offline, so that the data on your side will be consistent eventually after some period. But well, that's one of the challenges of working distributed systems, and that's one of the ways of decoupling them. Now, these two services, they don't talk direct to each other. They can still notify each other, but the Pulsar, the message broker in general, would act as our mediator, kind of black box, kind of decoupling infrastructural piece that will allow us to decouple these two services. And something additional that I wanted to talk to. So let's jump back into our Pulsar producer here. So there is a publisher. All right. So in order to maybe make things a bit more efficient, now, as you can see, we are creating this producer every time. So let's try to somehow maybe cache internally. So let's add something like private read-only concurrent dictionary string, and the producer you can see at the type of this variable is our iProducer of something. So in this case, it's going to be the iProducer of this read-only sequence of bytes. And I'm going to create a new dictionary, concurrent dictionary, so it's thread safe. So I'll call this one producers, and let's make a new dictionary like this. All right. And when I actually try to publish this message, I'm not going to create this producer every time, but instead I'm going to do something like producers and then get or add. So I will use the topic as a key for my producer. So if the producer is in my concurrent dictionary, I'm just going to fetch it. I'm not going to recreate it. If it's not in my dictionary, I'm just going to add it to my concurrent dictionary. So I could somehow make this a bit more efficient. So that's one thing. The other thing, is that sometimes you might be interested in sending your additional metadata. Let's say your correlation headers, maybe your tokens, certificates, timestamps, IP addresses, whatever you can think of. Whether this is going to be used for maybe auditing purposes, you want to know what are users doing, what are, let's say, employees doing in your system, or maybe for logging purposes, authentication purposes, authorization purposes, whatever you can think of. And in most of the message brokers, you can use some kind of metadata. For example, in the RabbitMQ, which works also with the AMQP protocol, you can use headers, just like in, for example, HTTP, where you could assign some additional HTTP headers. So let's assume that we would like to, for example, send some metadata. So we can do the following. So let's say metadata equals new metadata. Metadata equals new message metadata. We have this type built into the Pulsar library. So I can construct a new message metadata now. And let's say I will provide here something like producer equals producer name, like this. Or I will do something like custom ID, whatever my convention is, underscore, Pascal case, snake case, whatever. This is just going to be a key within my dictionary. And let's say custom ID equals GUID, new GUID to string n, right? Like this. So I can provide my metadata here. And then when I send my message, I can also send this additional metadata along with the message. And finally, on my, let's say, subscriber side, I can access the metadata. So for example, here, when we receive the message, what I can do is that internally within our message is that when I receive this message, I can ask, let's say, for the producer equals message dot, and then we have this properties, and for example, let's say producer, or let's say custom ID equals properties and then custom ID. And now let's see if this is going to work. So I'm just going to log this additionally from, and let's say producer, like this, and then let's do with custom ID. And let's say like this, custom ID, okay. And let's see if we can access this metadata being set by us. So the publisher sets some metadata and the consumer can receive this metadata. So let's start the aggregator. Let's start all the services and let's see if we can receive this data. So I'm going to start the aggregator, the quotes, the notifier, and let's see if the data will be there for us. So let's run our data feeds for the pricing, for the currency pair values, and we should see our event being sent along with this metadata. So just a second, and here it is. Let me stop this so we can see the logs. And there's our data, as you can see, received a message with this ID provided by the Pulsar from FeedR aggregator with custom ID. And voila, that's it. And sure, this is just a tip of an iceberg, and certainly we could achieve much more with the Pulsar, as it's pretty feature rich and very nice performing library. But really, whether you are going to use Pulsar, Kafka, RabbitMQ, Azure Service Bus, or any other kind of message broker / service bus / event streaming infrastructural tool, just make sure you read what are the capabilities of each of these tools, what are your actual needs, whether you need to have some kind of message broker, maybe the RabbitMQ will be a better fit. Whether you need to have some kind of event streaming capabilities, then maybe Pulsar or Kafka will be better approach, better idea. So just make sure that you will do some research first, and you will read about the features of all these tools that are out there, because there's plenty of them. And yeah, then just look for the library, look for the support within the environment, within the .NET or any other language that you're using. See if you can plug easily into this message broker or any other service bus event streaming tools. And then just think of your business events and start doing this async integration, this async decoupling, which is one of the better ways to actually decouple your microservices. And that's all for the 9th episode. As you have seen, we have exchanged the actual messages, these so-called integration events, between our aggregator service and our notifier service. So we have simply assumed that, for example, the aggregator service could, let's say, based on some user-defined rules or some maybe even artificial intelligence or some algorithms, it could, for example, decide that maybe based on this currency pairs values or based on this weather, temperature, whatever there is, it could, handle some application or business logic and then produce some events. So we just simply went with something as order placed. Let's say we want to sell some currency pairs, we want to sell some values on, let's say, on a forex or stock exchange or whatever it is, and we have automated this using our sophisticated lines of code. But the goal was to show you how we can think of producing the events and what are the important aspects whenever you think of starting plugging in the message broker into your microservices. So not just to think about the data, the payload itself, but more about the meaning of the specific message by looking at the message name, and in most cases to never lose this message. And even if this message will be, let's say, processed after some time, maybe a few minutes, because the service would temporarily be unavailable, this is still fine for us, because due to the nature of some processes, some business workflows, like for example the typical e-commerce workflow, when you make an order, pay for an order, start a delivery, due to their asynchronous nature, the customer, the client of our app, this person is aware that this is the process that takes time. So we decided that it's more important to us to adjust to this asynchronous process and to deal with the potential eventual consistency than to switch to our already discussed in one of the previous episodes, for example, HTTP, instant immediate communication, and then having to deal with possible retries, service being offline, and so on and so on. So that's all. Thanks for watching and see you in the next episode.